Hello guys. Every few years the tech industry picks up a new word, a term, and absolutely beats it to death. Right now that word is, you know it, AI. It's on your phone, in your browser, it's on the thumbnail of this video, most likely. And for the most part, although the technology is undoubtedly real, seeing so much AI words on the internet feels mostly like marketing fluff. So when TerraMaster reached out and told me they were launching a newer, the Pro version of their F4-425 NAS server, but with the world's first AI native operating system, I had two reactions. First, I was very excited about the specs of this thing because on paper it looks exactly like what a NAS consumer prays for in terms of specifications. And the second reaction was skepticism because at its core, a NAS is supposed to be a safe, quiet box that holds your files, manages your backups, serves your media, and so on. So why on earth would it need an AI, right? Anyway, I just unboxed this thing and ready to start setting it up. But before we dive right in, I wanted to get the transparency out of the way. TerraMaster did send this unit to me early so I could do this review. But as always on this channel, there is no script approval, and TerraMaster are watching this video for the exact first time, along with all of you. So my opinions are, as always, entirely my own. So for people who maybe don't know the naming conventions of TerraMaster and where this device sits in TerraMaster lineup, let's look at its name. The F4-425, so the F4 stands for the 4 bays that it has. So it has 4 bays for the hard drives inside, and the 3 numbers designate the target performance area. For example, 424 is aimed at beginner home segment, and it's usually an older generation processor than the 425. And the suffixes, the Plus, Pro, or Max, denote enhanced versions in the same lineup. So usually you have the same bay count, but it has a more RAM, a faster CPU, or additional features like multiple fast ports. Like over here, it has 2 5 gigabit Ethernet ports. Now, inside this F4-425 Pro is the new generation 8-core N350 processor. Next to that, there is 16 gigabytes of DDR5 memory. And although I mentioned that there are 4 hard drive bays over here, TerraMaster calls this configuration 4+3 architecture. So next to this 4 bays that you see here, there are 3 additional slots for the NVMe drives, the M2 NVMe SSD drives. Fully populated, this box can hold up to 144 terabytes of raw storage. And in a world where mechanical drive prices are hurting our wallets, and also SSD prices especially, this architecture can help us to do something clever. So for this review, I'm going to use 2 4 terabyte Seagate Iron Wolf drives, 1 high performance 980 Samsung Pro NVMe drive, and also an old mismatched 2 terabyte desktop drive Seagate Barracuda that I had lying around. And we're going to pull together 2 4 terabyte drive and 1 2 terabyte drive using the TerraMaster T-RAID system, which allows you to actually make a RAID volume out of mismatched drives. And the NVMe drive we're going to use for the hypercache functionality to speed up the performance of this drive. First, let's get this box running. The NAS itself has a very easy to understand construction. You have your primary ports in the back, 1 USB 3 port in the front, and the power button. To install the hard drives, you just push the front tray latches slightly inward and slide the tray right out. You don't need screws if you're installing standard 3.5-inch drives into it like this. You just secure them with the built-in pins on the sides of the plastic trays. They're also cushioned by the rubber rings over there to stop mechanical vibrations from vibrating through the chassis. Just keep the drive orientation correct and slide them back right in. But as I mentioned, the F4-425 Pro has the hidden hybrid layout. Getting into those internal M2 NVMe slots is also pretty straightforward. You'll need a screwdriver here, You can unscrew this nice solid aluminum side cover, and then you slide it off the base. Then on the side of the main board you'll see 3 NVMe slots, and right next to them is an upgradable DDR5 sodium RAM slot. It comes with 16 gigs out of the box, but you can also expand it up to 32 gigs if you want to. Installing an NVMe drive is standard. You slot it into the slot, secure it with a small screw, and it's ready for operation. Given that there isn't a massive amount of open space for cooling inside this enclosure, I opted for a slim heatsink for my Samsung 980 Pro, though looking at the clearance inside, you could probably comfortably fit a thicker one if you need to. For this review, I only populated a single NVMe slot, but because there are 3 available, you can really tailor this NAS to your exact use case. Since this NAS comes equipped with dual 5 gigabit network ports on the back, this box can theoretically move data across network at 1000 megabytes per second if you link them up. Standard mechanical drives cannot match that speed. They usually cap around 150 or 200 megabytes per second individually. So if you run a small media company or a studio where multiple editors want to work off a shared network drive at the same time, filling those internal slots with NVMe drives is a great option. Now, because I only have one NVMe drive on hand, my initial plan was to use the mechanical drives purely for mass data and install the core operating system on SSD for fast booting. I then wanted to use the leftover space on the SSD to store my app data for instant loading and partition a small segment to use as hypercache. Hypercache is TerraMaster's proprietary SSD caching software built into the TOS. Hypercache can turn the SSD into the invisible intelligent buffer layer that sits directly on top of your slow hard drives. It dynamically tags your storage habits, identifies your most frequently used files known as hot data, and mirrors them into the lightning-fast solid-state silicon so that the system doesn't have to wait for mechanical drive splatters to spin up. However, the way how TOS 7 handles storage logics makes this multi-purpose setup, like I just described, impossible. So you will have to make a choice. You can use an NVMe SSD to install the system on, or use it as a standard data volume for apps and files, or use it exclusively for hypercache. If you think of it, that kind of makes sense. By isolating hardware caching workload to its own hardware, they ensure it won't fight with your operating system for bandwidth or take down your entire server if the flash drive fails. So it's a nice choice for the system stability, but it's a total logistical nightmare if you don't map your physical installation steps before installing the hard drives inside. In my case, dedicating the whole 1 terabyte NVMe drive just for system partition would be a total waste of time. And running hypercache alone also didn't make sense, since I don't have a high number of concurrent users constantly hitting random files on this server. The only smart option left was to make a RAID volume out of my mechanical drives for mass data, install the operating system on them. And this is actually an important factor. TerraMaster allows this setup unless you use the leftover space afterwards on the mechanical drives, so I could configure the NVMe drive as a standalone fast data storage volume where I could isolate all my heavy application data like Docker containers and so on. To install the NAS operating system, you just type the standard tnas.online URL into your browser or locate the local IP address of the NAS inside your router settings. From there on, the installation wizard guides you through the setup. During it, you have to choose what type of storage pool you want to build. Classic configurations like RAID 0, RAID 1, RAID 5 are all available, but TerraMaster also includes their own custom options called T-RAID. To explain this, a traditional RAID 5 array, where any single drive can completely fail without losing your data, strictly assumes that all your drives are the exact same size. Since I wanted to use a mismatched collection of drives, 2 4 terabyte arrays and 1 2 terabyte drive, a standard RAID 5 would force the system to limit the available space on the 4 terabyte drives to just 2 terabytes each, wasting a massive chunk of storage. With T-RAID, however, the system uses dynamic partitioning to achieve that same single drive parity while utilizing way more of the leftover space. This is great if you don't know how you want to upgrade your storage in the future. If you want to slowly buy bigger drives over time, you then can just expand the T-RAID volume bit by bit. It's a fantastic quality of life feature, especially with current hard drive prices. So I fired up the wizard, clicked create T-RAID pool, and walked away to let it build the parity background sectors. Except I made a mistake, and many of you probably caught it during the intro already. I really didn't think it through. I thought it would be a great idea to demonstrate the beauty of T-RAID by throwing in that smaller 2 TB Seagate Barracuda desktop drive I had lying around. But because of the underlying technology inside that specific drive, I ran into a massive wall. Even after a couple of hours of waiting, the UI still showed me that pool was stuck at miserable 9.9% sync progress for the T-RAID. And it all comes down to a technology of that drive called SMR, Signal Magnetic Recording. The 4 TB Iron Wolf drives are proper NAS-grade CCMR drives. They write data cleanly in straight parallel lines. But the Seagate Barracuda desktop drive, it uses SMR, meaning it physically overlaps its data tracks like shingles on a roof to save manufacturing cost. So if you take one massive lesson away from this video, let it be this: if you have a NAS, never mix cheap standard desktop drives into a high-performance NAS array. Anyway, after taking out the Barracuda drive, I restarted the process and was left with a perfectly healthy T-RAID volume, giving me 4 TB of total usable storage with single drive redundancy, and I probably will later expand it with another 4 TB Iron Wolf drive. And alongside our independent 1 TB NVMe volume for apps. So, you access the TOS 7 interface on your PC via standard web browser, or you can also use a dedicated app on your phone. TerraMaster also provides a NAS-type desktop client called TNAS for your computer to manage automatic synchronization and backup tasks, but more on that in a moment. While the system does take a little bit of time to fully boot up from a cold start, since it still has to spin up those mechanical drives, the moment it loads, the experience is incredibly snappy. Navigating the interface feels completely fluid. There are no microstatus and no strange visual glitches, even though you access it through the browser. You have your clean desktop workspace, a performance dashboard on the right, and a main application dock sitting at the top, containing your settings, file manager, and system shortcuts. So let's quickly go over the settings that you have on the NAS. The control panel settings inside the TOS 7 are incredibly thorough and divided into several sections: privileges, network settings, general settings, and system info. Under privileges, there are user settings, places where you define shared folders, and more complex settings like domain privileged rules and application-specific rules. Then under network settings, you can configure your hardware interfaces, set up a Wi-Fi if you have supported USB wireless dongle connected, manage your local discovery options, and control your file services. The file services this is where you toggle exactly how your local computers access your server, whether you want to use standard SMB for Windows and Mac, NFS for Linux machines, FTP, WebDAV, or an rsync server, everything depending on your layout. This is also where you can enable remote access using TerraMaster's own built-in feature called TNAS Online. As long as you link a TerraMaster account to the server, you can securely connect to your NAS from anywhere in the world. It operates on the same basic principle of a secure tunnel, for example like Tailscale, but it's built directly into the operating system by the TerraMaster themselves. You obviously don't have to turn this on if you want to keep your box entirely air-gapped from the web, or you can easily install standard Tailscale later on it instead. But okay, moving on to general settings, this is where you can handle things like region and language, power preferences, scheduled tasks, system notifications, security rules, and firmware updates. And finally, in the system info, you have real-time device monitoring, graphs, drive health logs, and diagnostic charts as well. Since this is a network-attached storage device, I want to talk about connectivity options and file services. And I was very impressed. So the versatility here is solid, and you can connect just about anything to this F4-425 Pro, whether that means plugging external storage drives directly into the USB ports, mounting remote network folders through standard protocols like SMB and NFS, how I already mentioned, or linking even your mainstream cloud storage accounts like Dropbox, OneDrive, and Amazon. And of course, you can connect an existing NAS if you have one at home already. One of the first things that I did, since I wanted to stress test the media playback capabilities later, was migrate my movie and show library over from my old home server. So the process inside the Native Files app was very seamless. I just mounted my old server via SMB and started moving a massive 1 terabyte data pool across the network. At that point, the speed peaked right about 109 megabytes per second. And if you know your hardware, you're probably asking why so little. A modern T-rate array running through those dual 5 gigabit ports on the back should easily pull well over 200 or 300 megabytes per second. And the culprit here isn't the NAS or the Ethernet ports, it's my main router. So I have a TP-Link router which only has 1 gigabit lanes, like many people. And even though this TerraBox box is packing massive 5 gigabit connectivity options, my existing home network layout is just strangling it. Just to be clear, this isn't an issue with the hard drives or the SSD, because even if I were transferring data directly onto this lightning fast NVMe drive, a standard 1 gigabit network cable hard caps your physical speed at this exact 109 megabytes per second limit. Normally, to fix a bottleneck like this, you'd have to go out and buy, well, a multi-gigabit router or dedicated 5 gigabit switch. Thankfully, while digging through the advanced network settings, I actually found a brilliant built-in workaround that TerraMaster's engineered for this exact dilemma, and it's called Network Bridge. So let's say if your main editing PC only has one single network port, plugging it directly into NAS usually means you lose your internet connection. But with this bridge feature enabled, the NAS acts as an intelligent pass-through switch. You plug the first port of the NAS into your regular router for the internet, plug your PC directly into the second high-speed port on the NAS, and boom, your computer gets full internet access through the server while maintaining direct unthrottled fast lane straight to your editing storage pool. It's a fantastic option that completely eliminates the need to buy the extra networking gear, and you can still get the fast up to 5 gigabit connection to your NAS. However, even if you don't want to do it, don't fret, because for standard, let's say 4K media streaming running background Docker containers and automated phone backups, a standard 1 gigabit line is still perfectly fine anyway. While we're on the topic of file connections and data management, I also want to talk about backups. TerraMaster includes what they call BBS, the Business Backup Suite. When you launch the app, you're greeted with a very comprehensive diagram explaining the entire layout, which I put on the screen for you. So I'm not going to explain it in great detail, but I do want to explain the tiers of the system that is built right into the core OS by TerraMaster and into every desktop application from TNAS. So, what does it offer? First, centralized employee backups. Let's say you have a lot of employers, so then the NAS can simultaneously run full system proactive or passive backups from multiple employee workstations across your local network. Second, server and virtual machine protection. It can handle automated snapshots and state backups for your standalone virtual machines if your team runs them. Third, 3-2-1 strategy replication. BBS facilitates automated offsite replication from your local server to a remote TNAS unit alongside real-time cloud syncing to enterprise services, for example, Google Drive, AWS, or OneDrive. And fourth, ransomware protection. Because BBS leverages the underlying copy on write capability of the BTRFS file system that you have on this NAS to generate system snapshots, your data is protected from ransomware since it's only read-on mode. So, if you're a business owner with multiple employees, workstations, and external servers, all of those enterprise options are fantastic. But what if you're a content creator, a solo professional, or a home user? You probably just want a seamless, frictionless private cloud that backs up your personal laptop, your editing rig, and your mobile phone without any headaches. And for that, TerraMaster includes TerraSync. In practice, TerraSync is a much simpler, highly elegant tool. You can basically think of it as your own private subscription-free iCloud or Google Drive clone But at your home, you install the desktop client on Windows or Mac OS, or download the mobile app for iOS and Android, and it immediately opens up three distinct syncing behaviors. First is a two-way sync. You modify a file locally on your laptop and it will instantly mirror to the NAS storage pool, or you change it via the NAS web portal and it will be pushed straight down to your computer. Second, one-way upload and download. You can force specific folders to exclusively back up to the NAS without cluttering, or set up a distribution folder that automatically pulls updates down from the server whenever a change is detected. And third, on-demand space saving. This is a massive feature for laptop users with small internal SSDs. You can right-click a file to download it instantly when you need to edit it, and click free up space to send it back to the NAS when you're done. As a solo creator, this is my absolute preferred way of managing my active data. I work on my master project files locally on my machine, knowing that a perfect backup copy is being quietly mirrored to my server in the background. And obviously, you can run those exact same automated camera roll backups straight from your mobile phone. Needless to say, the main benefit of all of this is total privacy. Your data remains yours, hosted in your room, and accessed only by you. Okay, since we covered the physical storage and the backup pipelines of this NAS, let's check out the application ecosystem. There are two main distinctions that I want to bring up early on. TerraMaster has a dedicated app center as part of TOS 7 that allows you to install applications that TerraMaster themselves have officially approved and optimized. However, you can also install community applications that are not officially provided by TerraMaster. You can download and install these using .tpk or .deb packages via the manual installation option in the App Center. And there is also a Docker Manager application which allows you to install a ton of hundreds of Docker images, basically giving you access to hundreds of applications. So let me guide you through the main types of apps that are going to be of interest. First, let's talk about the media giants, Plex and Jellyfin. If you are building a home media server, those apps are your bread and butter. If you've never heard of them, it's basically like hosting your own personal Netflix network using your own media library, whether that's ripped Blu-rays and DVD movies or your own FLAC music archives. TOS 7 offers native installations for both Plex and Jellyfin. Because this Pro model is packed with a modern Intel processor containing built-in quick-sync graphics, it can handle real-time 4K video transcoding on the fly without breaking a sweat. Second, the Docker Manager. While community apps are nice, installing the native Docker Manager app means you can run pretty much whatever you want. If you've never used it, Docker is a container agent that lets you run an application inside its own completely isolated environment. This is right now the industry standard way of deploying software, so apps don't conflict with each other or mess up the underlying operating system. If there is an open source tool, server utility or home app you want to run that isn't officially listed in the TerraMaster store, you can just grab it from the Docker Hub and have it running on your isolated NVMe volumes in minutes. Third, virtual machines. If you need to run full independent desktop or server operating systems on your NAS for development or business tasks, you can do so either through VirtualBox or the native TerraMaster VMs app, which is a dedicated hypervisor built directly on top of Linux KVM kernel. If you remember, my apps data were set to install on the NVMe storage, so installing and running a Linux Mint virtual machine was super easy and fast. It was like 5 minutes and I could already browse the desktop. Fourth, Terra Photos. Instead of sending your personal family photos to Google or Apple and paying a monthly subscription fee, Terra Photos aggregates your phone backups locally. It utilizes the Intel's chip onboard graphics to process local AI facial recognition, object categorization entirely offline, protecting your privacy while keeping your photo library automatically sorted. On my initial import, it took about 5 minutes to index 100 pictures to map out faces, and then it instantly generated smart albums based on people alongside automatically generated places album using photos metadata. So generally quite nice. Okay, fifth would be the synchronization hub, what's called Claude-Sync. It allows you to bind your local NAS folders directly to cloud providers like OneDrive, Google Drive, or Dropbox. You can set it to run real-time bidirectional syncs, meaning you can get the speed of editing of local storage with a peace of mind, and then a copy would be instantly safely tucked away in the cloud even not on this NAS. And 6, Office. This is a full-blown Office suite, so you can edit your documents, spreadsheets, or slide decks right inside your personal cloud web browser. It is extremely powerful, versatile, works for you and your friends, colleagues, family on your local NAS, and it's basically like your own Microsoft suite at home. Now, this is definitely not everything. There are dozens of other applications you can install, like WireGuard, Tailscale, Edgard Home, and all kind of web development tools. So if you're interested in those, I'm pretty sure you can easily go online and check the full manifest. And finally, if you ever find yourself completely dissatisfied with what you can install on this NAS, know that the BIOS on this F4-425 Pro, just like any other TerraMaster NAS, is completely unlocked. That means if you want to, you can wipe the drive and install Unraid, TrueNAS, plain Linux, and configure the hardware exactly to your liking. So let's see how this new generation Intel 8-core N350 processor and 16 GB of DDR5 RAM performs under heavy load, and also how the cooling works on this machine. I opened up 5 independent browser tabs and started to simultaneously transcode and stream a 4K movie from this Jellyfin server. And I noticed that immediately the Intel processor pinned itself to an active 81% CPU utilization to crunch those videos on the fly. After processing those initial video buffers, it actually went down to 17%, and the hard drive read and speeds also completely dropped off. But even though utilization of the CPU dropped to idle, the internal chip temperature lagged behind and actually skyrocketed to 88 degrees Celsius, forcing the internal chassis fans to really aggressively ramp up to flush out the heat. And even though the CPU temperature then dropped to like 60 degrees Celsius, the fact that there isn't much fan options in this box means that it's probably a good idea to keep this NAS in a very nice ventilated place if you intend to use it for heavy workloads. And that buying an NVMe drive with a heatsink is a very good choice. I think at this point I covered all the usual topics for a NAS device. So now it's time to talk about something that I mentioned in the beginning of the video, the marketing absolute favorite new buzzword, which is AI. Unfortunately, getting to the actual AI in this first AI native NAS operating system is not so easy. And it might have something to do with the beta nature of this operating system that I was reviewing. There is an OpenClaw beta software pre-installed, and that is at this time the AI native layer on top of TOS 7. If you're unfamiliar with OpenClaw, it is what's considered an AI harness, so a wrapper around whatever AI model you want to plug in. It continuously runs whatever model you have until it achieves the task you give it. To do that, it requires whatever access to the system you're willing to give it, so you have to be very careful here. It can run and set up automated cron jobs, move files around, and actually in theory do more or less anything on the device. TerraMaster's version of OpenClaw contains custom skills and tools required to interface with the hardware. And in the case of questions related to the system information, it also knows exactly what tools it needs to call. I reviewed this NAS in its pre-release version of hardware running a pre-release beta version of TOS 7. And if you look at how TerraMaster explains this setup, they state that right now the most visible AI capability is this OpenClaw AI beta version. It's their very first implementation of a system-wide AI native framework, meaning you can talk to your NAS using everyday natural language to handle various management tasks, but it's still in the beginning phase. The long-term plan here is that these AI agents will eventually control everything on your NAS, your storage pools, your network configuration, backups, and your apps through a single unified chat window if you would want to. So in other words, yes, the AI architecture is already built into the core foundation of the TOS 7. OpenClaw is just the primary feature you interact with today, and more advanced application features will roll out later with future updates and new software skills. So with that out of the way, what did I actually try to do? Well, I live in Europe, so I decided to use a European AI model from Mistral. You can of course use any models, but some of them are way too expensive right now. And it's also not recommended to run a free or local model in OpenClaw initially, because OpenClaw operates in continuous loops. It forces your model to try the action you're asking of it until it succeeds, and an open model might hit a timeout. So after plugging a Mistral model in and setting it up, I asked the application what it can do. It greeted me, asked me to give it a name, explained also what its functionalities are. It was nice that it recognized itself as being on a NAS system running TOS and outlined functions that it can perform. That is great. The only problem here is that compared to the promise of ease of use for the user that is listed in the marketing material for TOS 7, there were a number of hoops just for me to get to that chatting interface. Setting up the model accounts, getting the API keys, configuring payment for the model on the Mistral website, and so on. At this point, I also was copying my files from the external NAS to my Jellyfin folder that I mentioned before, so I asked OpenClaw a simple question: can it see the transfer and tell me the status of the job? And unfortunately, it failed several times. It couldn't locate the Jellyfin folder inside volume 1 despite running the correct bash command. It only realized that the folder was there after I explicitly told it so. And then it just gave up on checking the size of the folder after its command timed out. Only on the third time, upon prompting, did it try to estimate the size of the folders. Unfortunately, it also did it completely incorrectly and then gave me a generic response on the status of the job, which was actually still going in the background. That was not very reassuring. Perhaps it was the model. I know the Mistral, a large model, it's a multi-model AI model that can deal with many contexts, audio, visual, and text, and it's a fairly good choice for AI models itself. Plus, many people have reported good use cases with it in OpenClaw. But for further use, I decided to try a model from Anthropic. I've read online that Claude-Sonnet is a great tool for OpenClaw, and it would work very well. On the first session with Sonnet, it actually gave me a really comprehensive summary table about my system architecture, my storage volume usage, and my hardware specs. That was reassuring, so I asked it to help me with my Security Advisor app settings. However, OpenClaw tried to run the background scripts to collect the data, ran into gateway execution loops, and sadly failed completely with a system error saying the assistant failed before producing content. It proceeded to give me step-by-step instructions on how to manually resolve the issues myself because it realized it couldn't run command without manual CLI authentication. That was nice. However, in practice, I doubt I need to use an AI to figure out those things because TOS 7 is pretty well documented. There is a help resource from TerraMaster themselves. And finally, in the case of Security Advisor, it actually directly tells you what you need to change in the app itself. In fact, if other applications don't start or they require permission, they also directly tell you what to do. For example, in case of Virtual Machines app from TerraMaster, it explicitly needed a virtual switch configuration in the network settings, and it pointed me to where I should go and put those settings in without any AI. Right, so here I was, using paid models from Mistral and Anthropic. At this point I had run up a couple of bucks in API costs, and to be honest, achieving very little. That got me thinking whether relying on an external cloud model for OpenClaw would be a way forward because it costs you money. Would it perhaps make more sense to run a local one? I decided to take things into my own hands and look at running a local model entirely inside this NAS. If I'm buying an expensive premium 8-core machine, I don't want to spend extra money on external cloud tokens just to watch them crash, right? I opened up the Docker Manager in TOS 7 and downloaded the official image for Ollama. Ollama, next to thousands of other applications right there in the registry, and it's also an AI harness. So a quick call out to our earlier section about installing apps on this thing. As I mentioned, if you can't find something in the official list, there are plenty of Docker containers available. Docker assigned a random local port 34693 to the Ollama endpoint, and then I jumped right into the terminal to run the initialization command. I decided to pull down the highly optimized Llama 3.2 3 billion parameter models from Meta. You might ask why the 3 billion parameters? Because you have to run it on this internal N350 chip. It doesn't have a dedicated graphics card with massive VRAM, so that it would have to process all the mathematical matrices of AI entirely on the CPU and the system memory. So I tried to run out these 3 B1 and also the normal Llama 8 model inside the console for a chat assistant, and as a standard chat interface it actually works fine. So if you ever want a local, completely private AI assistant for simple questions, don't forget that you can actually run this directly on this F4-425 Pro. But I wanted to try it with OpenClaw, so I went straight back into the OpenClaw's model configuration panel. I pointed the API base URL to our custom local port and check what happens next. So here I set up a split screen layout on the desktop to monitor the hardware telemetry in real life, which you can see right now on the screen. And on the left side, I have the OpenClaw running our local Llama 3.2 model. And on the right side is the TOS resource monitor dashboard. I hit it with a simple agentic prompt, check system health. Immediately the mechanical impact on the server was intense. The CPU utilization went up to 91% load, driving the temperature to like 80 degrees Celsius. It also took some time to process the query. I believe it was like 4 or 5 minutes, much longer than just using it as a chat interface via Ollama internal, mind you. But then it started to execute tasks. And here's kind of the ultimate punchline for this whole test for me. I'm showing the logs on the screen, and if you look closely on it, OpenClaw triggered the web search tool and literally Googled the phrase system health checker via DuckDuckGo. Pulled down a massive wall of public search results, and then in the final chat bubble it proudly speaks back at me. Based on the search results, it appears that there are several ways to check the health of your Windows system. Go to Microsoft Support and download the PC Health Check app. And I'm sitting here at my studio desk on a Mac web browser controlling a TerraMaster Linux NAS server running a local open source model, and the artificial intelligence is confidently telling me to download a Windows 11 diagnostic utility from Microsoft. So where does it leave us? On the AI front, I would say this needs some serious polishing, both from the technical implementation but also from the business use case perspective. The technical implementation needs improvement, as you just saw, and from the business perspective, this is a professional NAS, an expensive machine that with functionalities that would suit a business rather than a hobby user. Running an autonomous framework like OpenClaw on it right now might not be a very good idea. AI models make mistakes, give you false information, hallucinate, or execute something wrong. This was a very fascinating experiment, but for real day-to-day life, this is simply not ready. I do think that an AI assistant for configuring the best possible operating mode for your NAS is a great way to go for in the future. So I hope this functionality gets fixed in the full TOS 7 release. Right, so let's bring this entire timeline to a final verdict. If we look past the marketing noise, on the hardware side, this machine is an absolute treasure. And the processing performance out of that 8-core Intel N350 chip is incredible. And when you pair it with fast DDR5 memory, independent NVMe storage volume, the underlying speed of this box is really undeniable. If you're running a small office, a boutique creative agency, a media production team where you need to run heavy resource intense virtualized containers or multiple virtual machines, this hardware will handle it perfectly. The app collection is endless. The settings and configuration options fit just about any kind of the use case, and features like the network bridge are generally brilliant engineering choices that will save you from buying extra networking equipment. However, the edges of software implementation is where things get a little bit complicated. Outside of the OpenClaw AI implementation being very much a work in progress, the standard storage configuration and app workflow paths could still use some refinement. For example, the way TOS 7 handles app storage directories can get confusing. If you install an app onto a specific volume, uninstall it, and later try to reinstall it onto a completely different drive pool, the system will stubbornly attempt to deploy it back to the original volume location anyway. And to actually force it to change paths, you have to manually dive into the file directory with an SSH terminal session and completely delete the hidden add apps folder under the volume structure. It's a strange software quirk that can easily trip up an average user. And the way how the storage configurations need to be arranged also requires a little bit of a learning curve. Ultimately, this is not a budget hobby box or a casual device for a basic home user. The reality is most everyday users simply do not need dual 5 gigabit network connectivity or the massive heavy computational resources that this Pro model puts on your desk. So if you're a user on a budget, just looking for a solid place to store your family files, you can always look at the 425 or older 424 models, which are still fantastic, highly capable choices themselves. Otherwise, if you need raw, pro-engineered hardware horsepower for heavy workloads, this machine is really a certified beast. Thank you to TerraMaster for sending this early unit out for me to review, and thank you, dear viewer, for watching. I hope you liked it, and I will see you in the next video. And given that this is the Intel's new generation 8-core N350 chip paired with 16 GB fast, so this operating system